Hi, our group will be presenting an experiment which is Archimedes principle and Buoyant force that was being entrusted to us as a task. Our group name is Group 14 that was being led by Nurin Batrisha and assisted by Wan Muhammad Abi, Wolfness Justin and me, Salman. The objective of our experiment are to demonstrate the Archimedes principle and to measure the buoyant force of any object.
Hello, my name is Wolfness Justin and I'm going to present the introduction of this presentation. Archimedes was an ancient Greek physicist who developed a principle named after him after realizing that the substance of something may be identified if its density and displacement in a fluid are known. According to this concept, the upward buoyant force experienced by an object in a fluid is equal to the weight of the fluid displaced. The object will float to the top of the fluid if the buoyant force is greater than the weight. Meanwhile, the object will sink to the bottom if the buoyant force is less than the weight. If the buoyant force equals to the object's weight, the object will be totally buried in the fluid but floating in the middle. The buoyant force is proportional to the density of the fluid, as well as the volume of the submerged object and gravity.
For the experimental procedure, the potato was tied to the hook of the spring balance by using a string, and then the overflow vessel was filled with distilled water. The water was emptied from the level just below the nozzle of the overflow vessel into the beaker to ensure accuracy of the data collection during the water displacement. Later, the water in the beaker was removed and any presence of water was ensured to be removed to avoid any errors during the measurement later. Next, the potato was weighed using the spring balance and the data was recorded. The potato was immersed completely into the overflow vessel, and then the water above the level of the nozzle was seen to be displaced into the beaker. The displaced water was poured into the beam balance and the weight was taken and recorded. The weight of potato immersed in the water was measured using the spring balance to show its apparent weight and the data was recorded.
So my name is Nurin Batrisha and I will be presenting on results and observations, data analysis and also discussion. So for the result, first, we measure the absolute weight of potato before submerge using spring balance and we got 125 gram. Then we measure the apparent weight of potato after submerge using spring balance and we got 13 gram. Next, the weight loss of potato after submerge is 112 gram, and also we calculated for weight of displaced water before submerging, which is 0 gram, and then weight of water displacement after submerge is 110 gram. Proceeding to next, as for our observation, after the immersion of the potato into the distilled water, the weight of potato is lost by 112 gram on the spring balance reading, which we get by observing through the apparent weight of potato after submerge using spring balance. And then we also got the beam balance shows the reading of 110 gram for the displaced water, which we measured after displacing water. And then we see that there is a 2 gram error of the difference between the weight loss of potato immersed in distilled water and the weight of the displaced distilled water. And this error will be discussed further during discussion explanation. Data analysis, and as for data analysis, there will be two data that will be analyzed, which is using first equation, which is buoyant force equals to force in air minus force submerged in water, and then for using second equation, which is buoyant force is equals to the weight of displaced fluid, which is based on the Archimedes concept. Okay, so for using the first equation, which is using theory, the force exerted by potato before submerged on spring balance is 1.2258 Newton, and then the force exerted by potato after submerged on spring balance is 0.1275 Newton or 13 gram. So based on this, calculating using the equation, which is FB1 equals to F in air minus F submerged, we got the FB1, which is equals to 125 gram minus 15 gram, which equals to 112 gram or 1.0983 Newton. Okay. Next is by using our second method, which is to prove the Archimedes concept, which is first we got weight of displaced water before submerged is 0 gram or 0 Newton. Then once the potato was being submerged into the water, we got the weight of displaced water after submerged, which is 110 gram or 1.0787 Newton. Then using equation based on Archimedes concept, we got FB2 equals to weight of displaced fluid, hence buoyant force using second method is 110 gram or 1.0787 Newton. Next, we will be proceeding to discussion part. Okay, so first, we will be discussing about error, which is as per stated before, our percentage of error is 1.79%. However, since the percentage is less than 5%, we concluded that the buoyant force calculated using both methods is approximately the same, which is 112 gram is nearly to 110 gram. We believe that the error based on this error is that there was a water loss occurred because of changing containers from overflow vessel to beaker and also into the beam balance. Next, we will be proceeding on discussion regarding the objective and hypothesis of this experiment. Now, for the discussion part, as per objective is we want to demonstrate the Archimedes concept about buoyant force and to prove that the concept is right. Archimedes' principle stated that the buoyant force or upthrust experienced by an object in fluid is the same as the weight of water displaced by the object once it is submerged in fluid. This experiment objective is to prove the concept related to Archimedes' concept with buoyant force, and this can be shown by submerging a solid object into fluid using string or spring balance. Okay, so as you can see in the figure, when a solid object is being submerged into a fluid using a string or spring, there will be three forces acting upon the object, which are T, tension force, W, weight, and also B, buoyant force. So tension force and buoyant force will be in opposite direction of the weight because we apply the equilibrium equation, which is force must be equal in opposite direction. Okay, so looking at this, we can conclude that we can come up with the equation of buoyant force equals to force in air minus force submerged, because when in air there was only two forces acting upon the object, which is tension and weight of the object. But once the object is being submerged, there will be another force which is opposing the force from the weight of the object, which is the buoyant force. Hence why the tension force is being reduced. Okay. So based on this and based on the result, in order to compare or prove the rightfully of the Archimedes concept, we calculated the percentage of error and we come up with 1.79%. Hence, we can conclude that we achieved the hypothesis and the objective is being demonstrated. And that is all for discussion.
Hello again. Okay, so we will proceed with the last part, which is conclusion. So, by the end of this experiment, all the objectives were achieved. That is to demonstrate the Archimedes principle and to measure the buoyant force of the potato. The relationship of buoyant force in this experiment is the buoyant force is directly proportional to the density of the fluid as well as the volume of the submerged object and gravity. The terms that was often used in this experiment is force, pressure, and specific gravity. That is highly contribute to the Archimedes principle. That's all from us. Thank you.